And hello! Hope you are all having a fine day today, and I hope you're prepared and ready as I'm going to discuss and teach the process of balancing chemical equations. Before we proceed, you deserve to know the context of why balancing chemical equations exist and why it is important for us to learn this.
According to the law of conservation of matter, matter cannot be created nor destroyed. A material may change states, but that system's mass stays the same.
To give an example, when you crush a piece of ice into pieces, it gets smaller. But did that missing piece disappear? No, they did not get destroyed into nothing. They only changed states. Matter cannot be created nor destroyed.
So that means that when a chemical reaction occurs, every single part of that chemical reaction must be present in the product of that reaction. If a reaction starts with 2 hydrogen atoms, the product must have 2 hydrogen atoms as well. Thus, we need to balance chemical reactions to avoid confusions and mishaps. Now that I have explained the basics of balancing chemical equations, let us now proceed to some actual examples. Here we have C3H8 plus O2 produces C1O2 plus H2O. This is an unbalanced equation. The first step into balancing this equation is to first count the number of elements present in both sides of the equation. So in this equation there are 3 elements involved: carbon, oxygen, and hydrogen. In the left side, known as the reactant, there are 3 C's, 8 H, and 2 O's. In the right side, known as the product, there are 1 carbon atoms, 2 hydrogen atoms, and 3 oxygen atoms. Our goal here is to make the number of elements in the reactant and product equal. In order to do this, we must tweak the number of molecules. To make it simpler to understand, I will refer to each block of elements and their coefficients as a variable. Each block separated by a plus sign will be referred to as a variable. So as it stands, we only have one of each variable present. A blank space is also considered as one. We need to change the amount of one variable to change the amount of elements within that variable. For example, if we change the number of this CO2 variable to 3, it will change the amount of C atoms and O atoms to 3 and 7 respectively, currently balancing the carbon atoms on both sides. When you add a coefficient to a variable, you multiply that coefficient to the amount of elements in that variable. In this case, we added the coefficient 3 to variable CO2, so first we multiplied the number of carbon atoms by 3. 3 times 1 is equals to 3 carbon atoms. Then we multiply 3 to the oxygen atoms, so 3 multiplied by 2 is 6. Thus we have 6 oxygen atoms in that variable. Making the coefficient 4 in this variable balances the hydrogen atoms. Only the oxygen atoms are now unbalanced. Then since there are 10 oxygen atoms in the right side, the product, we must now figure out a way to almost make the amount of oxygen atoms in the reactant side 10. Thus we add the coefficient 5 to the variable O2. 5 multiplied by 2 makes 10, so there are 10 oxygen atoms, thus balancing this equation. Let's try another example. Na plus S8 produces Na2S. First, we must do the easy move and add the coefficient 8 to the third variable to make the number of S atoms 8, the same as the reactant side. Changing the coefficient in that variable also affected the number of Na atoms, so now we must balance that now. Making the first variable's coefficient to 16 should equalize the number of atoms, thus balancing this equation. Now we have group molecules, the PO4 in the product side. We can approach this in 2 different ways. One way is to consider and multiply each individual element. Another way is to consider the group molecule as one variable or element unit. I recommend treating this as if they are a single element, as it makes things simpler. First, we start with balancing the PO4, as it is relatively simple to balance.